The next talk is from Colin Charles, and it's about automated MySQL failover with MHA. Have fun with that.
Hi. So, how many of you here use MySQL? Or have customers that use MySQL? Okay. So, how many of you have automatic failover for MySQL in place? All right. What do you use as a solution?
We tried several, right now we have
Corosync Pacemaker. Okay. That's a fair Linux HA. Someone else, I thought I saw a hand go up here. MMM, okay, that's from Multi-Master, okay. All right, so I'm here to talk to you about MHA and the fact that MySQL is getting better in terms of offering you automatic failover solutions. Quick question, who here is using MySQL version 5.5? And when I say MySQL, I mean Percona Server, MariaDB, the works. Okay, anyone using 5.6? All right. With 5.6, how many of you, do you turn on GTID, Global Transaction ID? Yes for one, no for the other. Okay. Anyone using something older than 5.5? 5.1? 5.0? Wow. Anything older than 5.0? Okay. That's a good baseline for me to know exactly what people are using. Good news is everything I talk about will work with things even older than 5.5, so 5.1 is supported as is 5.0. Who am I? I work on MariaDB. Have you heard of MariaDB before? Anybody heard of it before? Yes, maybe. I work on MariaDB at SkySQL. Previously, I used to work at Multiprogram. I was a partner there, and we merged with Sky. And long before Multiprogram, I worked at Sun because Sun bought MySQL. And the speaker earlier mentioned where he was from. So I'm from a country that you probably have heard of a lot of recently in the news. I come from Malaysia. So I heard Snickers, so I presume you've heard of it. I've had quite extensive MHA experience since 2011. I also contribute patches to it. A lot of it was, my first start with MHA was to get it running instead of just Linux on Solaris. Does anybody here use something but Linux? Okay, good. This is a good crowd. And SkySQL actually helped me work on MHA because I used to do non-recurring engineering work to extend it for their customers. My aims are pretty simple. I'm going to talk to you about why MHA, what it does, how it does it really. When you want to integrate it with something like Corosync and Pacemaker, it's entirely possible as well, so you can use it for virtual IP takeover. So you don't have to put that in scripts. Who uses MHA is probably pretty important as well, because you don't want to use something that some only tiny company uses or nobody uses for that matter. And then we talk about, is fully automated really a good idea? And also giving you best practices from what the industry actually uses now. How many of you have bought this book before, High Performance MySQL? All right, it is truly a really good book. In the 3rd edition, released in 2012. There is no 4th edition in the works, despite the fact that this is now outdated, because MySQL 5.6 is here, MariaDB 10 is here. But in that book, they only gave one paragraph to MHA because they didn't really have too much experience with people using it in production. There were people using it in production, they were just not talking about it. Anybody bought the MySQL High Availability book? Okay, not as many as the High Performance one. That's also a pretty good book. There is a 2nd edition coming out. I technically reviewed it. Unfortunately, the book is mostly only focused on Oracle technologies. So things like MySQL Fabric, MySQL utilities. It doesn't cover what's available in the community like MHA and so forth. There is no MHA manual besides the wiki page that exists on Google Code. But first, I presume everybody here knows what MySQL replication does, right? Yes? Okay. You have single master, multiple slave architecture. This is MySQL replication. It's not Galera, where every node. Anybody heard of Galera cluster before? Okay, most of you. Anybody using Galera cluster? One person. Okay. Galera cluster is truly also very promising for data center use as well as for your customers. I'd presume that if you're running high bandwidth Drupal or WordPress sites, it actually could scale out really well, especially if you have a lot of writes and a lot of reads, because the way Galera does it is that if a write happens, it happens on all nodes or no nodes. So the transaction will be reverted. Whereas the way MySQL is generally architected, the replication at least, is that if you write on one node, it'll then replicate later to a slave. And it may or may not happen depending on slave lag, depending on corruption, depending on bit flips, etc. Then, when it comes to promoting a new master, again, this is not easy. When the master fails and you have a bunch of slaves, how do you promote one of those slaves to become the new master without something like global transaction ID enabled? Because the new master obviously has to apply all the relay log events, and if your master has crashed, like the machine is gone, you may have lost relay log events as well. All the slaves also need to be consistent. You also have to force MySQL to reconnect to the new client, so that's usually reconnecting to new IP, or host, or maybe the host name, you need to hook it in with DNS changes. And then you've also got to make sure that all slaves start replicating from the correct binary log position, otherwise they may be out of sync. Now, this is complex to do manually, which is why many people don't have failover solutions for MySQL. You run master slaves, the master fails, you ping the ops, and then the ops does something to fix it. And usually it's a manual operation. MHA has been around now since 2011. It was mainly created by this one guy called Yoshinori Matsunobu for a company called DNA in Japan. They're a large games company. He's also an Oracle Ace director, and his current job is that he's on the DBOps team at Facebook. So no secrets there, Facebook is using MHA at scale. What is MHA overall? MHA doesn't have a logo. It's just, it's cobbled up by many people. MHA has an odd name. It's just MySQL Master High Availability Manager, Tools for MySQL. The goal is very simple. It's either for automated master failover and slave promotion, or manual one with minimal downtime. It's written entirely in Perl, so it's easy for you to extend, hook into other things. Like if you're using, say, Route 53 on Amazon, you can easily hook it into the API and get it to change IPs, get it to maintain your catalog database, and so forth. The code is open source. It's fully GPL. And in practice, you can get into production in anywhere between 11 to 20 hours, and that means fully scripted, fully tested. That means you've actually tested the failover and a recovery afterwards. And in all purposes for testing, you can get started even in 5 minutes if you have access to the internet. Key point, access to the internet. So MHA has got multiple usage scenarios. The first one is automating master failover. In case the master has died, it'll promote the slave to become a new master. There is also another option where you do scheduled online master switching. And why would you do that? Why would you actually want to do a failover, a scheduled one? Because maybe your master hardware is behaving badly, the RAID controller's battery is dead, you're upgrading MySQL. I mean, upgrading MySQL is not an in situ operation. Maybe you're detecting memory leaks. Maybe you want to do alter table, and online schema changes are still very rudimentary inside of MySQL 5.6. MySQL 5.5 didn't even support online schema changes. 5.6 has online DDL operations. This is also true for MariaDB 10. But for DML operations like and for Varka extensions, these are not supported inside of MySQL 5.6. They come in MySQL 5.7. So you probably want to make use of services like PT Online Schema Change, Oak Online Alter, and so forth. But you can't do this online. You have to actually get your master switched over for your purposes. Also, maybe you just want to use MHA for failover, but for virtual IP handling and takeover, you'd like to use something like Pacemaker. The Linux HA toolset is perfectly suited for this kind of operation. Overall, MHA has multiple uses. It has multiple modes of use. And you can use it with or without global transaction ID, where global transaction ID is something you only get in 5.6 and greater. As I said before, master failover is generally hard because MySQL replication is asynchronous. There is a semi-synchronous plugin in MySQL 5.5, but not many people generally use it. Anybody here using the semi-sync plugin for 5.5? Do people know there's a semi-sync plugin for 5.5? Yes. Okay, so MySQL 5.5 and greater actually has a semi-sync plugin, which we'll talk about in the next slide. But the reason why master failover is hard is because if you have ID 10 on your master and your master is dead, and slave 2 has a copy of ID 10, it's easy to replicate and identify unsent events to slave 1 and slave 3. However, if your master is completely dead, as in the hardware has failed, not MySQL has crashed, you may suddenly lose ID 10, and then you have to decide, do you want automatic failover where ID 10 is now lost, and you don't even have that on, say, slave 2? Because you then have to reapply this when it connects back to the topology later again. These are things you have to think about when you're doing automatic failover, which is why at places like Facebook, they decide if they want to do automatic failover or not. Semi-sync replication is kind of handy, because if for some absurd reason your master crashes, MHA can't save the binary logs, and the data is lost, as I said. But if you have semi-sync enabled, generally, you have got very minimal risk of the binary log only existing on the master, because it guarantees that at least one slave has received the bin log event. Now, semi-sync doesn't come for free. To guarantee that one slave has received the event, naturally, there is lag. So your queries will take longer to execute. Of course, this is getting better in MySQL 5.7. And if you've heard of, anybody here heard of web-scale SQL recently? Okay, web-scale SQL is something that the Facebook people are working with, Google, LinkedIn, Twitter, and so forth, to patch MySQL to work better at scale. And they have something called enhanced semi-sync replication or lossless semi-sync replication, and that is something that you'll see in later releases of MySQL. MariaDB has better semi-sync replication at the moment now, but I'm presuming not everybody here runs MariaDB 10, considering it just got released April 1st. So typically, MHA will monitor your replication topology. If it detects a failure, it'll switch to a candidate master, which you can specify. And otherwise, the most current slave will become the new master if you don't specify a candidate master. MHA checks to see if it fails to connect to a master up to 3 times. This is configurable as well. Maybe you want it to fail longer. Then it will run change master on all the slaves to the new master. And then it'll print to standard error. And optionally, you can set it to email a report to an address. And then it stops monitoring the topology. So each monitor node can monitor multiple topologies, obviously. But MHA will stop when it's decided that the failover has completed. This is actually done by design, not a software fault, so that you can go in and look at your topology fix it, and then start MHA back again. So from the previous graphic, what MHA does is it just promotes something to a new master, and then it does change master. A typical timeline of MHA is usually no more than 10 to 30 seconds in practice. When I say 10 to 30 seconds, I'm referring to the fact that a lot of this failover happens within your data center. So if you are using something like EC2, I presume this would happen, say, all in the North Virginia location for, say, EC2, not when you're using it across, say, North Virginia and Singapore. Then it would take longer, obviously. You can't beat the speed of light. Typically, within the first 10 seconds, master failover is detected. Optionally, you can check connectivity via a secondary network, because sometimes the monitor may not be able to detect that the master is alive, but if you go via a slave, it may still see that the master is there. This could be network connectivity issues. Optionally, again, there's about 10 to 20 seconds to power off the master, and this varies depending on the hardware you have. And why would you power off the master? Because you want to shoot the other node in the head. You want to ensure that suddenly the master doesn't show back up again and cause havoc to your topology, which can happen. Of course, if you're using global transaction IDs in MySQL 5.6 or MariaDB 10, this is mitigated danger. It takes a good 10 to 20 seconds to apply differential relay logs to the new master. So when I say 10 to 20 seconds, we're looking at a relay log difference or lag of up to even 100 megabytes in size, which is pretty large. And in practice, we've seen that it takes no more than 4 seconds at DNA, usually less than 30 seconds. In my experience, we've seen usually around 10 seconds for a full automated failover. It's pretty quick. MHA works by saving the binary log events from the crash master. It will identify the slaves. The monitor will identify the slaves. Then it will apply differential relay logs to other slaves. And that's actually the secret sauce. Then it applies saved binary log events from the master, promotes the slave to a new master, and then make sure all the other slaves replicate from the new master. It's pretty simple. Using MHA requires zero changes to your application. You, of course, have to make sure your application is now writing to a virtual IP. So typically, your app will write to a VIP. MHA will require you to have another instance for the manager. This is typically something that you could run in, say, a VM. You shouldn't run this on the same master or slave, obviously. But if you're testing, maybe you can do that. But seriously, you should have a dedicated VM or machine for it. And the beauty of the MHA manager is that it can monitor multiple topologies for you. It doesn't only have to monitor one topology. So if cost is an issue, it really is a bad issue. It's a bad excuse. Also, MHA doesn't build replication environments for you automatically. That is a do-it-yourself sort of thing, which is pretty easy when you're dealing with MySQL. Each and every member of your topology, that being the monitor, that being the regular masters and the slaves, require you to install MHA for MySQL-node. There are Debian and RPM packages available for all popular Linux distributions. It's relatively easy to install. I wouldn't do this manually unless you're running on Solaris. MHA node consists of 4 tiny applications. Save binary logs basically allows you to save and copy the master's bin logs for MHA to deal with. MHA deals in its own directory, so it doesn't actually affect your main MySQL directory. You apply differential relay logs, will find the differential relay logs events and apply missing events. And then there's purge relay logs, which, as it says, it just purges relay log files. There is a fourth file called filter MySQL binlog. It is now obsolete and is not used by MHA, but is shipped in the event that you want to trim rollback statements from binary log events. But this is deprecated because MySQL binlog, the tool MySQL binlog version 3.3 onwards already supports this feature. Typically, if you're using MySQL 5.5 or even MariaDB 10, you've got like version 3.3 of MySQL binlog. If you use MySQL 5.6, you have version 3.4 of MySQL binlog because it has binlog backup streaming. So, the MHA manager server is just a monitor server, as I said. This is, however, your single point of failure, so you can have multiple monitors if you'd like. Keep in mind that if this does fail, your application topologies continue working. The only thing that basically happens is that automatic failover is now gone. But overall, if this fails, it's not a huge deal. MHA Manager obviously has a lot more dependencies. It has something like 30 different dependencies from cpan. But if you install MHA for MySQL Manager, it will pull it generally all in from either you can pull it in from cpan manually, or you have packages. RPMs have plenty of packages for the cpan libraries, as to some extent do the devs. If you want to do this in an offline format, I can highly recommend a tool called cpan Mini and Mini cpan from Randall Schwartz. You can actually take cpan offline. And why would you use this in an offline fashion? And it turns out that people do run MySQL in an offline fashion with no internet, especially in defense. I don't know if any of you deal with defense in the data center, but they seem to be really paranoid about being off the internet, off the public internet. Configuring MHA. For simplicity's sake, we just call it app1.cnf. You can call it whatever you like. And the reason why we call it app1 is because you have app1, app2, app3, app4, and so on. There's also a global configuration file. We ship samples for all of this, which should be able to be quite easy for you to get started if you download it and read the documentation. So this is a little small, but the slides will be available. Up there, you don't need to specify if you're using a master. MHA will detect that it's a master. MHA, however, doesn't detect automatically the rest of your topology. And this is something like Galera cluster. If you specify one extra node, Galera can auto-discover the rest of your topology. MHA doesn't do that with regular MySQL replication. You can set an option, candidate_master equals 1. So you set priority. That basically means that would be the default. Maybe you have a more powerful machine. Maybe that slave is as equivalent to the master, for example. However, if there is massive slave lag, it will actually not be the candidate master, where massive slave lag is defined as more than 100 megabytes in the logs. Of course, there's an option to override that also. If you are replicating for geographical purposes outside of, say, one data center, and this is very common for disaster recovery and so forth, you can always set no master equals 1, and this is always respected. Even if this happens to be the most current slave, it is always respected. And it's relatively useful. And the latest release of MHA 056, also coincidentally released on April 1st, has another option called binlog. So instead of just server 1, 2, 3, and 4, you can also have binlog 1, 2, 3, and 4. And that's for binlog backup streaming servers that you can enable when you have MySQL 5.6 available. But since most people here are not running MySQL 5.6, I presume you're not even using the binlog streaming backups that are available. But it is available. MySQL 5.6 has been around and GA now for 14 months. If you're still running 5.5, I highly suggest looking at MySQL 5.6 or MariaDB 10. It's time to move. The default config file is something that you don't actually have to specify for each individual application topology that is being monitored. Here you set things like the username, the password, the SSH user. You can specify obviously different SSH users, and depending on how you want to configure it, you just have to ensure your SSH user that's not root has access to, say, the shutdown command. Full access to MySQL is a given. You can obviously move this information out for data protection purposes. We talk about that later as well. The secondary check script is something well worth enabling. Not enough people enable it because you never really know if the manager can connect to a slave and then the slave can still see the master. I highly recommend turning that on. The shutdown script makes a lot of sense as well. You definitely want to shut it down, and this has to be custom configured depending on the kind of servers you have. And if your servers are virtual instances like on EC2, you will have to hook that into an API, like maybe using Boto or something. The master IP failover script and the master IP online change script are pretty much almost exact to each other, except one is for automatic failover and one is for manual switchover. So you'd actually configure them to be the same. The report script is for you to also customize to ensure that it will send you an email, send you a text message, etc. when MHA has completed a failover. MHA makes use of SSH, and you should set up passphraseless logins between your servers. In theory, only the manager should SSH to everything else, but however, if you want to make use of the secondary check script, make sure that the authorized keys file is the same throughout your topology. Master HA check SSH will ensure to see if your SSH topology is correct. Can all machines SSH to each other? Once you see that the checks are okay, you should know that you can now move on to the next step. This is relatively easy to do, obviously. Now, this is the one that most people fail at, is when they run master HA check replication for the topology and then they don't see that the replication health is okay. If you don't see this message, MySQL replication health is okay, MHA is guaranteed to fail even if you somehow manage to coerce it to start. It shouldn't start, but sometimes being Perl, you'll edit it and it'll start. Common errors include the master binary log position is different, and this means you have some kind of replication drift. Maybe the read privileges are not set. Maybe you're using multi-master replication without read-only equals one set. MHA doesn't do multi-master topologies. That's what MMM does, but MMM is very fragile. If you use MySQL 5.6 though, or MariaDB 10 with global transaction ID, this sort of thing becomes a lot more sensible, where you can have more than one writable master thanks to having a unique transaction ID that is global. To run the MHA manager, you just basically say master HA manager, and then you again point it to your application config file. If there are errors, they are printed to standard error by default. You can obviously set this to also log to a file, manager_log in the options. You would be smart to use something like daemon tools when you are in production. So run this through daemon tools so that it will always constantly run. It's easy to roll this with Chef or Puppet, and there are sample Chef or Puppet scripts that you can roll with daemon tools available online with the package. Anybody use something besides Chef or Puppet here? No. So MHA, if you did all that correctly, is actually really easy to start. You can run these commands in less than 5 minutes on, say, 3 VMs, even now, with internet. So, the master IP failover script is something worth looking at and configuring, especially if you're going to decide if you're going to use a global catalog database where you now maintain a map between application names, the writers and the reader IPs, or if you're going to use Pacemaker to do the virtual IP takeover. Either way is supported by MHA, but the easiest way to get started is, of course, to use a catalog database, because setting up Pacemaker and Linux HA is generally quite complex. A shared virtual IP is really the easiest to implement, as I say here. And you don't have to do many changes. You just have to add a short little line to master IP failover. But if you're going to use Pacemaker, you have to also configure the HA resources as well. The master IP online change script is pretty much the same as the previous script, except that this is really just used for online maintenance. And when you're using it for online maintenance, you can set master state equals alive, equals dead, and so forth. And MHA will then execute flush tables with readlock, because this is a planned failover. In a non-planned failover, there are many ways to kill MySQL. Someone could have kill -9 did. MySQL could have segfaulted. Maybe the machine has died. It's impossible for MHA to then execute flush tables with readlock because the master is gone. So this is a much safer way, but this is something that is also for planned maintenance. And eventually we will also improve this to have backup locks available that Pacona Server 5.6 ships, which we don't turn on now because nobody else ships it. Testing a failover is crucial. I definitely say run master HA check status. You can kill MySQL via kill -9, issuing a kernel panic. You can shut down the server gracefully even. And you will see that MHA goes through a failover. You're more than welcome to parse the log, and upon completion, as I said, by design, it will stop running. If you want to do a manual failover, and this is very typical if you're going to do a schema change. If you want to do an online schema change and you want to do rolling schema upgrades with tools like PT Online Schema Change or Oak Online Alter, you will do a manual failover, in where you will say the master state is dead, you will do the online schema change, and then you'll bring it back into the topology in a ring format. This is also useful when you want to upgrade the server, MySQL version, you want to switch from MySQL to another server. This is perfect. For the purposes of testing, or if you really do want to maintain a catalog database and not use Pacemaker, you add something as simple as this, which basically calls ifconfig to bring the interfaces up and down. And you add this into master IP online change and master IP failover. Feel free to extend this for your environment, obviously. So how does it integrate with other solutions? Data isn't shared, so you don't need shared data resources. So you don't need to use something like DRBD when you're using MHA. So for this purpose, if you are going to set it up with Pacemaker, you really are just having the clustering software, the Linux HA tools, invoke master HA, master switch to take over virtual IP addresses. Now, to install Pacemaker on Linux, and if you happen to use Red Hat Enterprise Linux 6, which is the latest, you'd actually have to use the CentOS packages because Red Hat charges you huge chunks of money to buy their HA add-on. Anybody here using RHEL in production though? Or is it all CentOS and Debian and Ubuntu? Okay, so there are people using RHEL. So the easiest way is to use the CentOS packages, which seem to rebuild the Linux HA stack. You need to configure HA resources, something similar to that. You can get this working with Corosync and Pacemaker easily. We've done this in production quite often. So the choice is yours, catalog database or Pacemaker. Since no one here is using Solaris in the data center, I don't really have to talk about this except the fact that Solaris doesn't have many tools. The OpenSSH is old. But on the bright side, because it's old, it doesn't get affected by Heartbleed. So, what about replication delay? 100 megabytes is the key. If MHA notices that the slave is behind by 100 megabytes, it is never the candidate master. If you really want it to still be the candidate master, and when you do that, let's say you have the logs are behind by 150 megs, it's just going to take a lot longer to apply the differential relay logs, and it's going to make your failover take a lot longer. So you really want to set candidate master equals 1 to a slave, and you think it may lag, you want to set check replication delay equals 0 as well. So MHA knows that you will, no matter what, you want that slave to always become the master. This is important because slave lag is a common problem in the MySQL world. However, if you're using MySQL 5.6, there's something called multi-threaded slaves as well as parallel replication. Now, the performance is better than regular single-threaded slaves. But if you compare the performance to MariaDB 10, MariaDB 10 literally gives something along the lines of a 9x performance improvement on parallel replication and multi-threaded slaves. So what that actually means in reality is your slave is basically as fast as your master, if not faster, because of the multiple threads that are being opened. So if you have a high bandwidth environment, that may be worth looking at. And it's likely that MySQL 5.7 will get these improvements too. But MySQL 5.7 is still probably quite some time away out, maybe a year out even. You can integrate it with PT Heartbeat if you also like to check replication delay. This is not really required unless you want additional checks. I'm sure many of you use the Percona toolkit, have heard of it before at least. Now, if you're testing MHA, I suggest that you're SSH user and you install this as root. But if you're deploying it, I suggest you have a user that has appropriate privileges depending on what you want it to do. Be it control MySQL, or be it shut down the machine as well. My advice is make sure SSH works on all hosts, not just from the monitor to all hosts, but between all hosts. You generally may face issues with putting plain text passwords inside configuration files. Like typically where we deploy a lot of this in, say, Korea, they have data protection laws. I'm not sure what the status is here, but you can't put plain text passwords in config files. There is an option for an initconf load script, which you can then seriously restrict the permissions on that file and just let MHA read it. So it is still on disk, but restricted. Each monitor can obviously monitor multiple topologies. So that's why I say app1, app2, app3, app4, and so on. Standby masters. So many people in topologies don't only have one master and many slaves. Many people have one master, a standby master, and then many slaves feeding off both of them. This is perfectly okay. Just make sure you set read-only equals 1 on the standby master. And then, by default, if you have topologies where you have one master, multiple masters underneath that one master, and then multiple slaves underneath each and every master, which also does happen. By default, that will not work unless you set the multi-tier slave equals 1 option, and then MHA will monitor that just as well. Replication users have to exist on all your topologies, so even the candidate master. This is another way to have a gotcha. What about alternative solutions? There is the option of not using MHA and using heartbeat with DRBD. I'm sure most of you are using InnoDB. Is anybody using another storage engine besides InnoDB? MyISAM? Anything else? No? For most people who are using InnoDB, you can obviously make use of DRBD and heartbeat. And unfortunately, DRBD has overhead. DRBD is obviously expensive because you have a passive master. It is equally powered, and it's just passively sitting there. DRBD has performance loss because you have to enable InnoDB flush log at transaction commit equals 1 and sync bin log equals 1. When you enable that, you are guaranteeing the D in ACID, the durability of your writes. How do you guarantee the durability of your writes? You have to not every time there is a write, you have to call fsync. Fsync calls are generally quite expensive. So the general way to mitigate this is to use something like group commit in the binary log. Group commit in the binary log basically means if you have anything more than 3 parallel running queries, instead of calling fsync 3 times, it will group those commits and call fsync once. And this increases tremendously, so group commit performance is generally amazing as opposed to not having group commit. So again, you want to use something like MySQL 5.6, Percona Server 5.5, Percona Server 5.6, MariaDB 5.3 onwards. And MariaDB's group commit, and again, MariaDB is generally leading the way in group commit, so every time MariaDB makes a new release, group commit performance is better as opposed to regular MySQL. And Percona will usually port the group commit fixes. That's how they got it for Percona Server 5.5. So if you are going to make use of DRBD, or even if you're not, running replication with group commit enabled will enable you to turn on InnoDB flush log at transaction commit, as well as sync bin log equals 1. Then there are alternative solutions that say you don't have to use this asynchronous replication or semi-synchronous replication. There is MySQL NDB cluster. Anybody here use NDB cluster in production? No, okay. NDB cluster is not InnoDB, so that's a huge disadvantage. And NDB cluster happens to also be require a minimum of a 5-node setup, 2 data nodes, 2 SQL nodes, 1 monitoring node. And it just doesn't work out of the box with many apps easily. As I said, it's not InnoDB. InnoDB is probably the most well-known out there. There's also Galera cluster and its variants, MariaDB Galera cluster and Percona XDB cluster. This is a great option because it is still InnoDB. But scaling out more than, say, 12 to 15 nodes has shown the general contention because you're writing to all nodes as opposed to just one node. Galera has improved tremendously in the 3.0 release, in where you can now have inter-data center communications where it doesn't send each write from every node across data centers, but it just elects one node to send it across data centers. So this improves performance tremendously. There is Percona Replication Manager, which is being improved. It has got a huge amount of tie-in with Linux HA, and also a lot of code from MHA to help. And then there is a Tungsten Replicator. Has anybody heard of Tungsten Replicator before? Okay, one person's heard of it. Tungsten Replicator basically replaces the MySQL replication layer with its own replication layer. Usually the packets are, the replication packets are about double in size of regular MySQL replication packets. And what it does enable, though, is replication to things like Oracle, database back and forth, Postgres, etc. This is a completely third-party solution, and most of it is open source, but the deployment tools aren't, so it's not something I am too hard on about. Now, if you are using MySQL 5.6, and at least some in the audience are, and only one has turned on GTID, you can make use of something called MySQL Failover. It comes as part of MySQL utilities and only works with, obviously, MySQL 5.6 GTID turned on. MHA works with everything, even without GTID. Here, the target topology is very simple. It's just one master, many slaves hanging off of it. You can't have master, multiple masters, multiple slaves, no multi-tier options. It's written in Python as opposed to Perl, so it is likely to be a lot more easier to manage, but it's also very rudimentary. So far, we know nobody that uses this in production, but many people definitely test it. You have to also enable log slave updates, report host, report port, master info table. And when you enable log slave updates for GTID, it increases the log space being used tremendously on disk as well. Here, the modes are also pretty simple. You can elect, which is choose from a candidate list, or auto, or it'll have fail. There are 3 modes, and the default is auto. Here, because you have GTID enabled and the transaction IDs are global, it is quite easy to then auto-detect slave topologies. So there is an option to discover slaves login to automatically discover the topology. And it is likely we will improve this in MHA to also do this only when the host has GTID. Again, the monitoring node is a single point of failure, and unlike MHA, it's not something where you can run 2 monitoring nodes independently of each other. In testing, when you have SQL errors, which sometimes hit the slave, it will prevent a failover. And there is one good benefit, though, is that if you do restart a node, it will rejoin the replication topology as a slave. This is a very positive feature that we definitely would like to obviously get into MHA as well. So this is what you'd call as failback. So not only does it do a failover, it fails back upon recovery. The problem with GTID, though, is that all your masters and slaves need GTID enabled. So upgrading is not easy because your entire master and slave topology needs to be restarted at the same time. This means downtime. Nobody likes downtime. This will improve in MySQL 5.7, but in the current 5.6 stage, it is pretty broken. And GTID has bugs. Like in 5.6.10, when you reconnected to a master, it basically scanned all the binary logs. So in 5.6.11, this was fixed, so just scan the head. But scanning the head also takes minutes. So overall, this is a potentially good tool for the future, maybe. But at the moment, as it is today, this is not something you'd want to deploy because most people don't even have GTID turned on. For those of you using MariaDB 10, it is worth noting that the GTID implementation is different from MySQL 5.6. GTID is always turned on by default. There is no way to turn GTID off. And you can get the current global transaction ID position by doing @GTID_pause, selecting it. But generally, if you want to change masters, it's made the code inside MHA simpler, and it's something you can also do manually. You just have to stop the slave, change master to master host, and then start the slave. We expect that the ease of use of GTID in, say, MariaDB 10 will eventually make its way into 5.7. In fact, if you see the 5.7.4 labs release, there are ways for you to start GTIDs without restarting your entire topology. Because restarting topologies is just not practical for production users. Where is MHA used? DNA, obviously. It's used at Prem Access, a Swiss hosting company. Jet Air Belgium uses it, and they did a popular case study, so I think they're an ally in Belgium, obviously. In Korea, where I spend a lot of time, Samsung, SK Group, which runs the second largest telco, And DARPA, Defense, Korean Defense Agency, also runs MHA. And Facebook obviously still runs MHA, though they don't run it in a fully automated mode. And I can say this in public because they also mention this in public. When they detect a failure, they will notify ops, and the ops will decide to wait or failover. Because if it's just a reboot or a crash, at most this is a 20-minute downtime, which is easy for you to wait. I mean, if you are the user, when you click like, your shard just doesn't get updated. You get an error saying you can't. Please try again later. However, if it's a hardware failover, a failure, then the ops will definitely do a failover. So the trade-off here is between data loss and downtime. And they use MHA. They're not planning to change from MHA. They contribute actively to MHA. And this is just something to think about. MHA 056 was released literally just last week. There is quite a lot of activity on the project on GitHub. So this is not something that's like dead or created by one person or two people. There are easily 8 people now that have committed to the code base, including people at like Media Temple. So if we know that they must be using it as well if you're writing code. And Easy Flirt, is that a website in Europe, I think. MHA 056 has some interesting features. You need 0 configuration changes to handle GTID-based failover, but 056 now supports GTID plus auto-positioning enabled, so the syntax will just work. MariaDB 10, unfortunately, doesn't work yet with GTID because they were both released on the same day. You might be wondering why a lot of software gets released in the MySQL world in April, and that's because there's a big MySQL conference in Santa Clara. So we practice conference-based releases. MySQL 5.6, as like MariaDB 5.3 onwards, also supports checksums in binary log events. And checksums are good because if it detects a checksum mismatch, replication will stop. It also supports multi-threaded slaves. You can have MySQL binlog, as well as your MySQL and custom locations. And 5.6 has something called binlog backup streaming server, and that is now also supported by the binlog number option. You can now obviously change variables dynamically without restarting servers. Binary log checksum is a runtime option as well, so you can force rotation of the binary log. When MHA does do GTID-based failover, it will check binary log servers. And if the binary log servers are ahead of other slaves, MHA will apply differential binary log events to the new master before recovery. When it does traditional non-GTID-based failover, it will ignore the binary log server. So the binlog server's streaming backup thing is new in 5.6. And that's something you get in MySQL binlog version 3.4. There's also an improvement in the sense that previously it just checks to see if the server is alive, but now there's also ping type equals insert, which you can set inside the configuration file. And this basically checks to make sure that the master is still accepting writes, because sometimes if it doesn't accept writes, there could be a disk error. And in the future, there's also a resource agent that you can download for MHA, that if you want to use it with Pacemaker, available at that website. I'm going to ship it inside. And also MariaDB 10 GTID handling. Is fully automated a good idea? Well, when you have a false alarm, it can cause very short downtimes. So maybe restarting all connections is probably not a good idea. This happened at GitHub sometime last year. They were using a mishmash of Percona Replication Manager, and it basically caused false alarms and then repeated failovers. And then it brought GitHub down for maybe some 6 hours, and everybody became very productive for a moment. If there are repeated failovers, by default, MHA will not allow you to do a failover. So if it detects something in the last 8 hours in its log directory, it will not allow such a thing to happen, unless you set last failover minute equals n, and n is in minutes. So by default, 8 hours. Data loss. You have to think about data loss, because if the latest commit ID is, say, 103, reader logs at 101, you have loss. Can you afford that loss? And can you afford to wait for that loss to the server to come back up and then manually apply these things? And then sometimes you got split brain because power off takes a long time. When you're using things like the cloud, powering off cloud instances is not instantaneous. It's much slower than using something like MeTool on the HPs or Telnets on the Dells. Much, much slower. In fact, spinning up instances are also really slow. MHA is, so you have to think if you want to do fully automated or not. In all my experience with deploys and with talking to people, about half would do fully automated, and about another half do it manually. They'd get notification, and then they'd decide if they want to do a failover or not. Huge chunks of companies support MHA, so this is not just unused, unsupported software. There are plenty of automated tools you can play with. There's a Vagrant setup. There are Ansible playbooks via Palomino DB, now known as Blackbird IT. There's some video resources. If you want to see a talk by the original author a couple years back, it's about 15 minutes. Quick introduction to MHA. If you want to see a comparison between MHA and Tungsten, also another video available for you. That's about half an hour long. There are multiple there's a design document. The configuration parameters are definitely worth looking at. The use case for airline is generally quite interesting. And if you've never read about the MySQL binary log and the replication API, it's really worth looking at, because not only does it support all these wonderful things, it also allows you to push data out to Hadoop HDFS via Hadoop appliers. Facebook has managed to use the binlog API to create something called Wormhole to also push data directly elsewhere. And people like Tungsten make use of it to push data down to Hadoop. The replication API is definitely worth a read. I mean, MySQL supports getting data out via the replication API and the storage engine API. Well worth looking at those things. And with that, I have time for questions. Slides will be on SlideShare as well as the conference website. Any questions? I presume we still have at least 2 minutes. Yes.
Okay, I did not
1 second, please.
Oh.
I did not completely understand the replication issue. We have servers where we do operations and other people do database changes. Mm-hmm. And so I'm not sure if I can run this software when I do not know who is doing schema updates at what time.
So the schema updates in MySQL doesn't happen by itself. You have to use a tool like PT Online Schema Change or something, right? You're using MySQL 5.5, 5.6.
Yes.
Yeah. So before you want to run PT Online Schema Change, you can make use of this tool to ensure things have stopped. You need to flush the tables, lock it properly, and then only do a schema change. So it's entirely possible for you to use this tool.
Okay, if I know, but you never know, it's a very big organization who's doing schema updates at what time and if they honor the replication setup.
So doing a schema update, like changing things in MySQL, has never been an online operation. So it's unlikely they're adding to the database, they're adding more rows, but they're unlikely changing the entire schema, because that has never been an online operation. Okay. That's a MySQL deficiency. So, and it's getting better. 5.6 includes DDL. 5.7 will have DML, but you can definitely use the tool.
Okay.
Even in a big organization.
Okay.
Facebook has thousands of instances. The last public number was in the high 6s. I have to be careful. I can't reveal things naturally. Any other questions?
Okay, then. Thank you very much, Colin.
All right. Thank you.